All right, hello, folks. I don't know why camera's not working, but hey, you don't need to see my face, so you just go over the problems, right? As promised. First of all, since I rushed at the end, a lot of you folks are like, "Oh, how do I work with this thing?" So let's go over this a little bit more in detail. So here, this was my game plan. When I looked at limit up 2 times sine of 5 theta or 3 theta as theta approaches zero, right? Uh, you see that how do I approach this from with a direct substitution? We got 0 over 0 there, so we're like, what technique can we use? Can we use one of this, one of that, or can we use the trig identity we can possibly work with? So that comes with an experience, right? Like which strategy works best for us, right? But at this point in time, I'm like, oh, this looks awfully familiar. It kind of looks like sine c theta over c theta. So somehow, if I can manipulate this, then I can find the limit of that as theta approaches zero, which will give me 1. By the way, some of you folks from uh, your summary that you're saying that sine c theta over c theta is equal to 1. That's not the case, folks. It's actually sine c theta over c theta is, it could be a lot of different numbers depending on what theta is. Uh, but limit up this whole thing as theta approaches zero. Okay, theta approaches zero will give you 1. Okay, for example, limit up sine c line. Sine theta over theta as theta approaches pi over 2 will actually be sine of pi over 2 over pi over 2, which will give you 1 over pi over 2 or 2 over pi. So it's not equal to 1, is it? And 2 over pi is actually around the ballpark 2 over 3.14. And that, yeah. So don't think of sine theta over theta is always equal to 1. It's just limit of that as theta approaches 0 is equal to 1. Okay? This is equal to 1. Not sine c theta over c theta is equal to 1. Okay? I want to make that distinction. All right, so back to this problem. So if I know that stuff, I almost cursed. All right. If I know that, then you work with this guy. This is my technique. Let me go over a little bit more. Is first of all, I don't like 2 and 3 over here. Maybe I can factor that out before I make it into sine c theta or c theta. So that's where I have 2 over 3 that is factored out first, which will give me sine 5 theta over theta. So I almost have that form, but I need to make this into 5 theta. So what I do with the manipulation here is I multiply by 5 over 5 so that I can borrow that 5 to get the 5 theta. Why am I multiplying by 5 over 5? It's still a 1, right? So I'm not changing the value of this expression. I'm not changing the expression. I'm just changing the form of it. So when I do that, the 5 goes in here, so I get the 5 theta, but the numerator 5 actually stays at the top of there. And that's why I have these 3 parts here, as you can see. 2/3 times sine 5 theta over 5 theta. Oh, I accomplished what I wanted to do. And then I have times 5 here, which will give me, using a property of limit, as long as each of the limit does exist, I can rewrite this in limit of 2 over 3 times limit of sine 5 sine of 5 theta over 5 theta times limit of 5. Of course, you need to write this down. Not any value that is approaching, but theta approaches 0. I got lazy and I didn't write that down. And then this one will be equal to 2 over 3. That one, using what we learned today, will always equal to 1. then that 5. So when you multiply those out, it'll be 10 over 3. Yeah. Okay, let's go over the rest of the two. Okay, limit of sine 4 theta over theta as theta approaches 0. So here again we have a similar form here, but this needs to be 4. Right? But first of all, you need to do a direct substitution, which will give you sine of 4 times 0 gives you 0. So sine of 0 over 0, which is again 0, 0. So you're like, oh, I have to use one of those techniques to simplify this guy, possibly. This just means that our function sine 4 theta over theta is undefined when theta is equal to 0. But we might have a hole there, right? So work it out to find the limit, actually. So that means, what do I do? The next step is limit up sine 4 theta over theta, but I want that to be 4. So just like what we did over here, we're going to multiply by 4 to get the 4 theta. But then I don't want to change the value, so I need to multiply by 4 over 4, which will give me limit up sine 4 theta over 4 theta, right? As theta approaches 0, but you also have 4 over there. And this is even more simpler than that guy, right? So now you have limit up sine of 4 theta over 4 theta as theta approaches 0 times limit up 4 as theta approaches 0. Now what's lovely is this whole thing using this one again, right? It's going to be 1 times 4. So your answer, the limit value that you're going to get is 4 over there. How can you check this out? I mean, of course, this doesn't constitute the whole thing here, but if you, I mean, this doesn't prove algebraically where it's reaching, but if you actually graph this out using a Desmos, you learned today, right? This is sine 4x over x. Let's see, how's that going to look like? It's actually this purple guy over here, if you folks look at it. And do you see we're approaching 4, even though it's not defined. It's not defined when x is equal to 0, right? Because you get 0 over 0. But you'll see that it's approaching 4 over there as we get close to it. Right. So that's one way to check it out. This one, I want to give you some time to work on it. So right now, pause the video for a second and then work on number 3 and check whether you got it right. Okay, let me go over this. So that should be, first of all, if you do a direct substitution, you get a 0 over 0, right? Again, sine of 0 over 0, so 0 over 0. So after getting 0 over 0, what you're gonna have to do is manipulate it, and then this looks awfully familiar to, similar to that. So what you're gonna do is take out 1/3 as a factor first, and then you get sine of 2x over x. Almost there, but this is not 2x, so what can we do is make that a 2x, but you need to multiply by 2 over 2. So very similar, right? So right now, you're going to get limit of 1 over 3 times sine of 2x over 2x times 2, which gives you limit of 1/3. I'm just going to omit the x approaches 0. We're going to assume that we know that. Sine 2x over 2x times limit of 2 which will give you 1 over 3. That whole thing is actually 1 as x approaches 0, right? And then times 2, and you'll be left with 2 over 3 for that one. Not bad, right? Okay, number 5. Let's try number 5 now. Give me a second. Number 5 is, so we might have to first of all do a direct substitution, right? So that will give you tangent of 0 over 0. And tangent of 0, again, you got to use a unit circle. Right? And the 0 is here, right? 1, 0. And we established the tangent is y over x or sine over cosine, yeah? So here y is equal to 0. The x is equal to 1, so it will be equal to 0. So you have a 0 over 0 case here. Indeterminate form again, right? So how do you figure this out? Is it like, oh, I don't see anything that really helps me out here. It's a little tricky. So again, it comes with an experience. What you're gonna do is, maybe I play it this way. I know tangent of theta is equal to sine theta over cosine of theta, right? Or theta, so maybe this will help me out. And this is actually same thing as sine theta times 1 over cosine theta over theta, right? How is this gonna help me out? It's going to be limit up, and look at this manipulation now. Sine theta over theta, right, times 1 over cosine of theta. Ooh, pretty fancy, right? How is that gonna help us out? Look at this guy. What is that guy? This is that guy right here. Limit of sine theta over theta equals to 1, or sine c theta over c theta equals to 1. So here, assuming that each of these limit exists, I can rewrite that guy as times limit of 1 over cosine of theta as theta approaches 0. And guess what? That whole thing is equal to 1. And then do a direct substitution here with 1 over cosine of 0. And cosine of 0 is actually equal to 1. So you have 1 times 1 over 1, which is equal to 1. Huh. Shall we check that out graphically too? Sure, why not? We have plenty of time because this is a recording. Let me just say tangent of x over x, right? And let's see how that's, you know what? Let me create a new one. Just y equals to tangent x over x. And let me just get rid of all these guys, yeah? So how is that going to look like? Oh, okay. Wow. Look at this beautiful guy. Tangent x over x. So you'll see that it's undefined at 0. Right? At 0. So there should be a hole there. Right? There's a hole there. Oh, I see decimals, they do have a hole. Okay. And then everywhere else is defined around there. But you see that it's approaching 1 as we get close to x equals to 0. Yeah. Okay. Pretty cool, right? So it's equal to 1. So I guess graphical way is also another way to really check it out whether you're approaching that value or not. Checking your answer as well, right? Like we're using multiple ways of approaching it. Okay, number 6. How do you approach number 6? Oh, shoot. Let me stop this for a second. Okay. Okay. All right, folks. We're going over 6, 7, 8, 9 now. So limit of 2 minus 2 times cosine of 2 theta over theta. So how do you approach that problem? So way to approach that problem is, first of all, you're like, okay, we need to do a direct substitution first. Right? Direct substitution first. And then you'll see that it'll be 2 times 2 of cosine of 0, but you're squaring that. And then divided by 0. So what is cosine of 0? First of all, cosine 0, we need to look at this guy again, right? And then you have a 1, 0, so that'll be 1. So you have 2 times, 2 minus 2 times 1 square over 0, which will give you, I'm wasting too much space here, but you're going to get 2 minus 2 over 0, which gives you 0 over 0. Another case where it's undefined, at theta equals to 0, right? So direct substitution doesn't work, which means we'll probably have to simplify it. So how do I simplify it? So you'd be limit of, what's the game plan here? How can we work this thing out? So it comes with experience again. When I see this, I see some factoring possible here. Both of them have 2. So what I'm going to do is 2 times 1 minus cosine square of theta over theta. This still doesn't help me out when I substitute for 0. Okay. So what I can do is, if you folks remember our work from this guy, I told you can write down sine squared theta as a 1 minus cosine squared theta. And then 1 minus cosine squared theta could be rewritten as 1 plus cosine theta times 1 minus cosine theta, using the fact that x squared minus y squared is x plus y times x minus y. It's called difference of squares, right? So maybe that will help me out. Let's check it out. So here, I rewrite this as 2 times 1 minus cosine of theta times 1 plus cosine of theta over theta. Don't forget the limit, by the way. Limit of as theta approaches 0. And how is this going to help me out is, again, at first it's hard to spot that out. So it comes with experience. But when I look at this guy, folks, 1 minus cosine theta over theta, that looks like awfully similar to what we went over here, 1 minus cosine theta over theta. And we established that limit of 1 minus cosine c theta over c theta as theta approaches 0 will always equal to 0. So we'll use this fact to help us out here. So I'm going to break this apart a little bit. The limit of, factor 2 out first. 2 times 1 minus cosine theta over theta. That's one piece. So first piece and second piece, and times 1 plus cosine of theta. Oh, so assuming that each of the limit exists, I can rewrite this as limit of 2 times limit of 1 minus cosine theta over theta times limit of 1 plus cosine theta over theta, which will give me, that whole thing becomes 2, oh sorry, my apology, no theta here, it's just 1 plus cosine theta, because we're just talking about that guy. So 2 times, and what was this equal to? That was equal to 0. 0 is always nice when you're dealing with calculus problems, because anything times 0 is 0, right? And then here, you can actually calculate this out too. When you do a direct substitution here, there'll be 1 plus cosine of 0 And cosine of 0 is, again, equal to 1. So you have 1 plus 1 here, which is equal to 2. So now you have a case where it's 2 times 0 times 2, which will just equal to 0. So number 6 is going to equal to 0. Pretty cool, eh? All right. You can go back and watch it too. So I'm going to move on to number 7. Number 7 game plan is this. So you have a limit of 1 minus cosine theta plus sine 2 theta over theta as theta approaches 0. To save our time, I'm just going to let you know that when you do a direct substitution here, you get a 0 over 0. You can do that work on your own after you do a direct substitution. So that means I need to check it out so that we can work it out. So it might be looking really tough at first, but again, it comes with experience. Do you see 1 minus cosine theta over theta, and then maybe sine 2 theta over theta, which is similar to sine c theta over c theta. So you can work that thing out. So how do you approach this problem? We're going to rewrite this as limit of 1 minus cosine of theta over theta is one piece. Okay. Let me see who's asking the question. By the way, I'm recording this session, so a lot of you folks think I'm crazy when I'm doing this, but this video will be available to you. Yep, thank you, Sana. Appreciate it. Okay, your name is mentioned in this recording, just to let you know. All right. Okay, so you have a limit of 1 minus cosine theta over theta time, not times, sorry. It's not times, plus sine 2 theta over theta. Wait. So why is it not multiplication instead of addition? Is because there's no multiplication. It's 1 minus cosine theta plus sine 2 theta. And this type of algebraic manipulation is essential when you're dealing with a lot of calculus problems. Yeah, that's why you probably had a lot of practice with that in pre-calculus. And if not, then we'll practice it right now. Yeah. So 1 minus cosine theta over theta plus sine 2 theta over theta. I can break this into limit of 1 minus cosine theta over theta as theta approaches 0 plus limit of sine 2 theta over theta as theta approaches 0. We already know that what this value is going to be. That value is going to be 0. Again, going back to this, right? And then limit of sine 2 theta of theta. In order to manipulate this, I need to make this into 2. So what I do is I multiply by 2 over here to get the 2 theta. But I cannot just create the value out of thin air, so I have to do 2 over 2, which gives me limit of sine 2 theta over 2 theta. So I borrow 2 to get over there. But then we cannot ignore 2 over here. So what am I going to get is 0. Let's ignore 0 now because we took care of that. We just have to take care of that guy. That can be rewritten as limit of sine 2 theta over 2 theta as theta approaches 0 times limit. Now this is times, not plus. So limit of 2 as theta approaches 0, which will give you that whole thing becomes 1. Going back to limit of sine c theta over c theta as theta approaches 0 equals 1. And limit, and then this whole thing is equal to 2. So the answer for that is going to equal to 2. Pretty cool, right? Oh, shoot. Okay. Yep. And guess what? If you put this in the decimals, you will get that equal to 2. So pretty cool stuff. I mean, that's one way to check out your answer, right, folks? Is if you use the decimals, I can do it here, is that 1 minus cosine of x Was it plus sine 2x? Yes, plus sine of 2x. And then let's look at that graph. Ooh, beautiful looking graph here, right? And then you'll see that when x is equal to 0, it'll be undefined. Okay, there's a hole there, 0 undefined. However, it seems like it's approaching some value from right-hand side and the left-hand side, which is equal to 2, right? So even if you don't have a value, like undefined at x equals 0, you can still see that limit value is approaching 2 here. And then that's one way to check out whether you got the right answer or not. Let's finish the rest of it. Finish strong. Number 8. Limit of theta times cosecant theta plus 1 over theta cosecant theta. So first of all, we need to know what cosecant of theta is actually equal to 1 over sine theta, right? It's a reciprocal of sine. So all we are saying is we basically have, you can rewrite that as theta over sine theta plus 1, and this is also theta over sine theta. I'm not going to go over the whole thing again, but when you substitute for 0 again, you are going to get something that looks like 0 over 0. So what do you do after that? So you are actually going to simplify stuff here. Again, comes with an experience. Oh, I see the same thing over here. So what I'm going to do over here is, this is my approach of it. Why don't I just divide both sides by theta times cosecant theta, and what I'm gonna left with is basically 1 plus 1 over theta cosecant theta over 1, like that. So what I did was I divide both sides by, and both numerator and denominator by theta cosecant theta, basically. Pretty advanced technique, right? Theta cosecant theta divided by theta cosecant theta gives me 1. That's why I divided. And then theta cosecant theta divided by cosecant theta also gives me 1. But then I have a 1 over theta cosecant theta over there. That's how I got it. This simplifies a lot of stuff for me, because now I have limit of, I just have to worry about 1 plus 1 over theta cosecant theta. Theta approaches 0. And we established that cosecant theta is 1 over sine theta. So beautiful thing over here is actually, it's a reciprocal, right? Now I can write that down as sine theta over theta. Some of you folks are like, how can you make that jump, Mr. Kim? I'll show you. It looks something like this. 1 over theta times cosecant theta, the same as 1 over theta times 1 over sine theta. And I don't like sine theta over here, so how can I manipulate this function is I multiply both numerator and denominator by sine theta over sine theta, and that cancels away, assuming that sine theta is not equal to 0, that is. And then, I can rewrite that as a sine theta over theta. Get used to this type of manipulations, okay? I know at first you're like probably overwhelmed. It's like, oh, how do you know to use that? And that really comes with an experience again. So don't try to memorize it. Just try to get used to it. You're just building up the muscle in order to see the pattern and see how can you manipulate this out so that you can work it out. You just have to solve a lot of different problems. And then you have now you have a 1 and the sine theta over there. So you're like, limit of 1 as theta approaches 0 plus limit of sine theta over theta as theta approaches 0. Ain't that nice? This will be equal to 1, and that's also equal to 1, which is equal to 2. Cool beans, yeah? Again, you can go back to the recording and then check this out again, but I need a space for the last problem. Oh, and also on the summary activity, whenever we do a summary, let me know if my like way of conveying the message or going over the lesson is not suitable for you. Like, is there another way I can help you out? Right now, I'm using a lot of video, a lot of lecture lessons here. Do you need more visual cue or all that? Just let me know so that I can accommodate your learning that way. Yeah. Okay. So number 9 is the looks tough cookie, right? It looks like a really tough guy, but it's actually not so bad. And then here again, if you do a direct substitute, you're gonna get. I mean, this one is a little bit more intuitive, so I'm just gonna substitute for it and then do it. Other ones I need to do more work, and I wanted to save time, so I just skipped it. This one too, and then that one too. Now here, sine of 0 is 0, and then sine of 0 is another 0. Cosine of 0 is 1. 0 minus 0 over 0, so you have a 0 over 0 again in determinate form. So you're like, oh, okay, I'm defined over there again. So how can you simplify this guy? So way I look at it, I'm like, oh, this term both have a sine x and sine x. Maybe I can factor something out. It doesn't always work it out nicely, but maybe start off with that. Again, it comes with an experience, folks. So you just have to solve a lot of problems. So here's sine x. You can factor it out. Then there'll be 1 minus cosine of x. And then you have a over x squared. And some of you folks probably already see, 1 minus cosine of x, I saw it somewhere, Mr. Kim. That should be something like that. And sine x. And then maybe this is x squared over there, right? So here's one fancy way to break this up. So you say you're going to rewrite this as, instead of doing x squared now, x squared is actually the same thing as x times x, right? So I'm going to break this into limit of sine x over x times 1 minus cosine x over x. Do you see that? Pretty nice breakup right there, yeah? And then you can rewrite this as limit of sine x over x as x approaches 0 times limit of 1 minus cosine x over x as x approaches 0. How can I do that? Because I know each of this limit exists. What is this guy, folks? Is this going to be equal to 1 from what we learned from today's lesson, yeah? This guy. And then what is that second guy? That would be 0. So you have 1 times 0 case where the answer is 0. End of the story for that. Limit value is 0. And the main important part is how you've spotted out as sine x times 1 minus cosine x times over x times x. You can break this into sine x over x times 1 minus cosine x over x. And then, ooh, nice. That thing becomes that. And then this thing becomes that. And then each one of them is going to be 1 and 0. Ain't that lovely? And this is why, oh yeah, Kataya, you have a question? This one? One? Okay. From today's lesson, we learned the sine x over x. Do you remember this guy here? So sine of anything like c theta over c theta, when you try to find the limit of that as theta approaches 0, we establish that that's equal to 1. So we're going to use that fact to work it out. And this one, there's no other way around it unless you're going to use a trigonometry and squeeze theorem to prove it. But I told you, we're just going to use a graph and table to figure out that it's approaching 1 as x approaches 0. And graphically speaking, that looks something like this. Like sine 4x over 4x. As long as that is 4x and 4x, you will see that is approaching 1, even though it's defined at x equals to 0. No problem. I think that clarified a lot of people's questions. And so it was a great question. I like it. Before I wrap up this recording, any other questions, folks? And in the recording, I know you folks just joined in for independent sessions. So number 2 and number 3 and number 5, how I approach this problem is actually in the recording as well. All right, sounds good? Which means we're going to get to quiz review now for those of you folks who are already here. Okay, so let me just finish the recording.